Hey everybody, welcome back. We're going to be talking this week about OffChain Code, Beginner Web3. This is lesson 8 on iterators. So let's jump on in. If you've not taken a look at OffChain, go ahead and check out our WhatsApp or Telegram or WeChat groups. We also have our offchain.social website where you can find out about different cryptocurrency, blockchain, and other events happening likely nearby a city near you. Quick thing about myself, I've been living in Guangzhou for the past 3.5 years, although actually I just moved to Shanghai. So I guess I got to update this slide. But I've been doing cryptocurrency type work since 2013 and really am passionate about software development in general. I work at a large international bank, but I've worked in many different places. So feel free to reach out to me on my website or any other of my social media contacts here. We're not going to get into anything too deep in this course, but we're going to get over the basics of programming. And we're doing JavaScript really to give you guys a basic starting point to understand how this entire Web3 structure works, how it allows the internet the ability to maintain state on a blockchain and allow us to be able to work in a decentralized way. So let's jump right on into lesson 8. This lesson is going to be on iterators. So last time we covered loops. Iterators are quite similar to loops. They just actually simplify things down and give us some higher level programming that we can use to make things easier. So let's first talk about functions as data. Now we all remember back in the initial lessons that we learned how to assign variables. So JavaScript behaves like any other data type in the language. We can assign functions to a variable. Let that sink in. We can say, you know, let name equal Ben. We could say let age equal 37. And now we can also say let Ben equal human function, and it could go do stuff. This is quite interesting. So here's an example. Below, we have an annoyingly long function name that hurts the readability of any code in which it's used. Let's pretend this function does important work and needs to be called repeatedly. So they've done this one, const announce that I am doing important work. That's a really long name. There's nothing wrong technically with using such a long function name, but all your other programmers in your shop will be like, why is that function name so ridiculously long for something that's so stupid? And okay, fine. It's just going to simply execute out console.log. I'm doing very important work. Interesting. What we wanted to rename this function without sacrificing the source code. So how could we take this very long function and make it look like something else? Well, we can just reassign it. You can literally make a new variable, const busy equals the function. And notice how it's not putting any parentheses here. Normally when we do a function call, you need to include the parentheses for any arguments that you're passing. In this case, all we're doing is literally setting it to a variable name, but it's not a variable name, it's a function name. Interesting. You can then call that function by doing busy, and then again, parentheses. Because we're calling the function, you need to include the parentheses. Now, it's much easier to read busy parentheses with these parentheses than it is to fully write out, announce that I'm doing important work. So busy is now a variable that holds a reference to the original function. If we could look up the address and memory of busy and the address and memory of announce that I'm doing important work, they would point to the exact same place. So it's literally making busy equal, you know, announce that I'm doing important work. It's the same thing. Our new busy function can be invoked with parentheses as that name was originally gave our function. Notice how we assign that without parentheses. So again, it's very important. When you want to assign this variable to a function, do not include the parentheses. If you accidentally did, it would actually execute the function, and what you would be getting back is the return statement. So in that case, console.log would run, but there's no return. So you'd be setting busy equal to null. There'd be nothing there. There's nothing to pass. There's no return statement. Okay. In JavaScript, functions are a first-class object. This means that, like any other object you've encountered, JavaScript functions can have properties and methods. Interesting. Since functions are a type of object, they have properties such as length and .name and methods such as toString. And you can read all about all the different other options that are available in the documentation. But let's try some of these out. So we've defined in here, check that 2 + 2 = 4 a million times. Awesome. Okay, that's a terrible piece of code, but I mean, there's nothing technically wrong with it. This function takes a long time to execute. So if we click run, it does run a million times. So let's go ahead and run it. 2, 3, 4. And, on my computer, it ran reasonably fast. We got to a million within, 2 or 3 seconds or so. Not bad, but obviously not great because this is pretty pointless. Let's create a shorter name variable is 2p2. That'll be easier to read. All right. And we're going to assign it to check that it's the same. So we're going to put down here const, and we want to do is 2p2. That's the new name for the function. And what we want to do is assign it. So we're going to use the equal sign, and then we're going to pass in the old function. And since that's so horribly long, I'm going to copy and paste. Now, again, make sure you don't use parentheses here because we're not calling the function. We're just assigning. Let's try running it. Great. Now, if we wanted to call the new function, we would just have to type in is 2p2, and we now need to pass in the parentheses. This is letting the language know that we're intending to execute this function. Let's run it. And it does it. And it took, the same amount of time. We're now seeing that it's going to take, a long time. If we forgot the original name of our function, is there a way we could figure it out? Yes. Let's try. So what we'll do is use the console.log, and we can call is2p2.name, and let's see what happens. You'll see that is2p2 has a built-in property name, which references back to the actual original name, not is2p2, but actually check that 2 + 2 = 4 a million times. So it's permanently set the name to be this. Okay. You can try playing around with this. What would happen if I set the name? Are such things allowed? Is 2p2.name equal to new name? No. And so this is interesting, but you'll have to read the documentation to see what you can do and can't do, but interesting. All right, let's continue on.
I have a question, if I may.
Yeah, please.
Why would people not just directly use a shorter name instead of firstly using this huge function name?
That's a great question. Like, why would they go through this process of reassigning it to something else rather than just change the code up here? Is that your question?
Yeah, pretty much. Yeah,
and quite honestly, I would say absolutely go change the code up there if you can. What you'll find though is as you get into bigger programs, sometimes you're given a library, somebody else's code that you literally are not allowed to go change. And maybe they've done something where it's just really annoying to work with that function, or you need to use it in a different way and extend it in ways. For this reason, we then sometimes start doing this assignment where you might want to rename it or do something else with it to make it easier and or do different things with it than it originally did. I think what's this example here is it's pretty basic, almost too basic. It's too contrived to even make sense. Just realize that functions are a first-class object, that they're not just this one time and then thing that you can call only that way. You can actually reassign it and do things with both the name of both of the function and as well as the properties of that function.
Right.
It's a bit contrived. Good question though. functions as a parameter. Since functions can behave like any other data type in JavaScript, it might not surprise you to learn that we can also pass functions into other functions as parameters. So literally, it starts behaving exactly like a variable. A high order function is a function that either accepts functions as a parameters, returns a function, or both. It gets really, really confusing, but you can do that. We call the functions that get passed around as parameters and invoked callback functions because they get called during the execution of the higher order functions. Okay, stay with me. It's a bit confusing, but once you see a few examples, you'll figure it out. When we pass a function in as an argument to another function, we don't invoke it. Invoking the function would evaluate to the return value of that function call. With callbacks, we pass in the function itself by typing the function name without the parentheses. That would evaluate the result as the calling function. So let's take it slowly. Const time func runtime. And then we're defining this function func parameter, and we're passing in, okay, letting T1 equal date now, the function parameter, let T2 equals date now, T2 minus T1. We then const add 1 to 1. Okay. And then we're using const func runtime that we've defined up here, time func runtime that we defined here, and we can pass in add 1 to 1. So we're taking this very simple function and passing it on in as a variable on up here. So what's it going to do? So we wrote a high order function, time func runtime. It takes a function as an argument. We're taking literally one of the arguments is now going to be passing in this add 1 to 1. It saves a starting time. So it takes literally what is the current time at the start, invokes the callback function. So this is the parameter that was passed in. Remember, normally like when we define this type of function, like there's a parameter, well, this is now the parameter. It's literally called function parameter, and it's going to execute it. Why is it executing? Because we've told it to using these parentheses. It took the function parameter and executed it. Any function you want that you passed in will now be executed right here. It's then going to take a second time, and it's going to then do T2 minus T1. Okay, well, this 1 plus 1 is going to get executed. So it's going to return 2, but it doesn't really impact anything yet. Interesting. So the high order function can be used with any callback function, which makes it a potentially powerful piece of code. You have to be careful. Literally anything you pass on in here now is going to get executed inside of here. And so while we say it's powerful, because you didn't quite realize when you passed a function on in to this other function that it's going to get executed until you look at the code. Let's try it. So in this example, we invoke time func runtime with an anonymous function that counts backwards from 10. So here's time func runtime, and it's going to count backwards from 10. Anonymous functions can be arguments too. So let's get some practice on this. All right, save a variable time tpt, sorry, 2 plus 2, time 2 plus 2. Assign it as value the result of invoking the time run func time with the check that 2 plus 2 equals 4 a million times function. All right, here we go. So we have our original check that 2 plus 2 equals 4 a million times up here. And then we're going to save a variable time. So let's make a new variable. We'll call it let time tpt. Assign as its value the result of invoking the result time func runtime function. Okay, but it wants to that check that 2 plus 2 equals 4 a million times to be the parameter we pass in. Now remember, when you're passing a function on in as an argument and you want to pass it as the function, not the return, do not include the parentheses. If I did this, it would no longer be a function getting passed in. it would be the execution of that function. So what we're going to do is be passing in, check that 2 + 2 = 4 million times, just that. Run it. And we've passed. So remember, if you're trying to save, make a variable and then have it get the execution of another function, well, you need to type in the name of that execution of the function. To execute it, you need the parentheses. Oops, sorry. And then to pass in a variable that is a function, to have that being passed on in, do not include the parentheses. So with parentheses, gets executed. Without parentheses, no execution. Remember it. Write a high order function. Check consistent output. This function should have 2 parameters, a function and a value. It should call the argument function with the value 2 times. If the callback function produces the same result twice, it should return the result of the function call. Otherwise, it should return the string, this function returned inconsistent results. I think this is one of the harder type questions, and we may have to use hints. Don't be afraid if you get stuck to look for a hint, but let's try it out. Write a high order function. So all we're saying is just write a function, but it's going to now be taking in functions as parameters. So let's take an example. Here is a function that was written. We're going to follow this from line here. Pretty much this is a template that we can use. So this one's called const. And we want it, they've told us to make the function name called check consistent output. All right, that's our name. It needs to have 2 parameters, a function and a value. All right, to have something that takes 2 parameters, how do we do it? Well, we could try this, and we could take a value and do an assignment, and we want it to have curly brackets. It should call the argument function with the value 2 times. So we can just simply say check consistent output with the value. And it's saying call it 2 times. All right, we'll just do that twice. If the callback function produces the same result twice, it should return the result of the function call. Otherwise, it should return the string. So one way of checking this would just be to say if this equals the same thing. It says return the result. Well, I guess we wouldn't want to do execution again, so we really can't just do an if condition, can we? We probably should store it so it doesn't execute again, because depending on what we're executing, we wouldn't want that. So let's try doing instead a variable declaration. Result 1. Result 2. Now we can do our if statement. And if it is the same, it's saying return the result of the function call. So since it's the same, we can return either one. We'll return result 1. Else, return this function returned inconsistent results. All right, so this is an attempt. Anybody spot any issues? Let's see. Run. Uh-oh, I've made mistakes. Missing initializer in const declaration. We need to learn how to debug these type of mistakes. So it's saying missing initializer in const declaration. Const declaration equals, let's take a look at some hints to get some help on this one. Nothing there. If you're stuck, you can click on the Get Unstuck up here to get more help. Remember, when making the declarations, you need to make sure that if you have multiple declarations, you put them in parentheses. It's tricky. This is the hardest part, I think, of coding, is remembering some of these syntax things. And as we get into some of these more complicated lessons, remembering all the past syntax just keeps adding and adding and adding. So practice is really the only way to keep remembering it. When we saw then this comparison, you need to be thinking it's an if condition. But when I first started, I thought, well, why don't I just say if this execution equals that execution? The problem with that is then they want us to return the result. Because we're passing in a function, every time it runs, in theory, it could change. We don't know what that function does. So to make it consistent, I stored it to a variable. Then I always can return result 1 because it's not rerunning the result again. I hope that makes sense. All right. Invoke your check consistent output with the add to function we wrote and a number as arguments. Let's try. So to invoke a function again, we copy the name. We're going to be passing in check consistent output and a value. So it wants us to pass in the add to. Let's see, add to is defined up here. So all I have to do is specify add to as the first argument. The second argument is any other number. So sure, 1, 2, 3. Let's run it. So let's talk about what it just did. Add to. So add to is literally just doing any number plus 2. Well, if you run that twice, it'll always generate the same number, right? 5 plus 2 is 7. And if I pass in, that again, 5 plus 2 is still very much always going to be 7. But can you think of a case where it would differ? In the case of here, this time func runtime, the time changes. Every time you run this time function runtime, it's going to get a different result. Let's try exploring some idea here. So if instead of doing add to, if we pass in this one, oh, and I guess I have to pass in function parameters to that too. Yes. So we won't pass in that one because that one would actually require a function parameter that we've not specified when we go to do. Let's modify it. We'll pass in function parameter and it needs a value. Or not. What am I doing here? Function parameter. It also needs a function. We won't use that one as example. Try if you wanted to passing in another type of function that would change it. So what we'll do here instead is modify an existing function to do that. So instead of add 2 plus 2, let's say instead of adding here plus 2, let's instead add date now. No, it's not actually going to be doing anything with number. It's just going to generate two different date nows. Oh, and I have to pass that on in, yeah. Oh, and since we returned it, we would need to console it out. In this case, it is the same. We can see that it would result in the same date now coming on out. Okay, let's go on to the next lesson. So by thinking about functions as data and learning about high order functions, you can start thinking about how to abstract your code. Again, this is a more complicated subject, but it's allowing you to start seeing that you can do a lot with code and functions where you can make something that's more complicated, perhaps easier for humans to read. So if you have really difficult code, you can rewrite it. And you can pass these functions on in and assign them to new variables, and they behave just like any other object. We're going to talk more about objects here in just a second. Let's go into objects. So imagine you had a grocery list and you want to know what each item on the list was. You scan through each row and check the item. This is a common task. It's similar to what we have to do when we want to iterate over or loop through an array. So previously we were all using the for loop. Now we're going to be starting to use iteration methods, and these are called iterators. So iterators are methods to call on arrays and manipulate elements and return values. So in this lesson, we're going to be doing the syntax for these methods and see how they work. So looking at this piece of code over here, we have a ForEach. And if we look at all the different things being called, they're saying it's going over for each artist. So the artists are defined here for each Picasso, Kahlo, Matisse, tomorrow. It's going to print out the same statement. So this could have been done using a for loop, but the for each iterator makes it a lot easier to read. We don't have to keep track of what index we're on or increment +1. It just says literally in pretty plain English, for each one of those artists, just do this. Makes it quite nice. This is a very common task in programming, so iterators make things a lot simpler. So for each artist, we also have map and filter. So in the case of this, we could have numbers 1, 2, 3, 4, 5. And if you wanted to get the square of the number, you could take the numbers and you could map a number to then do a function, which is going to do the number times the number. So it's taking, mapping is similar to like a for each, but it's actually running an actual function each time. So it's going to then map the square numbers of numbers is going to be at the end. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. It's going to literally have now an object of the square of these numbers by using this mapping. Filter is similar. So if we had things, desk, chair, 5, backpack, 3, 14, 100. If we wanted to filter these things to say only return the numbers, again, I could write a for loop and say, is desk a number? No. Okay, don't return it. But the better way to do it is to use the filter. You could do things dot filter. Thing then becomes an iterator where we can then check to say for each one of these things in the things, you can call it whatever you want. Run this right here, say return type of thing if number. So it's going to return whether it's a number, and then it's going to print it on out. Let's try running all these. So we can see on the first one, the for each, print, 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 print. The for each makes it super simple to loop through an array. When we do the square numbers, what we're seeing now is console log square numbers, 1, 4, 9, 16, 25. So the map allows us to run a function against each element of a number in an array. And the filter, it's allowing us to literally shorten out the list. You know, previously we had desks, chairs, and backpacks tossed in there. Now all we're getting is only the things that we wanted to go and look for. And we can use, you know, any logic you want could be in this function. It's just in this case, returning back only things that are equal to a number. Very powerful. So let's go through each of these and some exercises. So in the for each case, const groceries, and we have some items that are being bought. We can then use the for each to help loop through these things. Let's try an example. Iterate over the fruits array, mango, papaya, pineapple, apple, and say, I want to eat a blah, 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 plus, for example, I want to eat a mango. You can use any form of callback you prefer. So to do this, let's take a look at the example again. We want to say, perhaps function print. What did we want to print? I want to eat. I want to eat. Sure, we can do that. And it's going to take an element. We want to console.log that element on out, but we wanted to also say, I want to eat, and then the element. So I want to eat a something plus that element. Once you have defined your function, we can then use a map, or sorry, a for each. I couldn't ahead of myself. So we can now say, print, I want to eat for each. No, it's the other way around. Fruits for each. I print, I want to eat. Remember, we take our array, and then using for each, we can pass in any function we want. And I've defined one up here that you can use. Okay. Let's try the map method together. So the map method is very similar. We're going to take some examples here. Add your code under the animals array, and before the line console.log secret message join, use the map to create a new array that contains the first character of each string in the animals array. Save the new array to a const variable named secret message. Oh boy, don't worry, let's go slow. So add your code under the animals array. So under the animals array, okay. Create the secret message array below. So in line 4 here, and before this next line. Use the map to create a new array that contains the first character of each string in animals. So we just want to be getting the first character, like H for hen, E for elephant, L for llama. Save that new array as a const variable named secret message. Interesting. All right, so const secret message, that's where we're saving it. So we know everything has to eventually get up into here. Now, what we want to do is use the map. To use the map, we have to first start with, well, what are we mapping against? Animals. Animals is what has the mapping. So we use the animals array, we call .map. Each time that we call the map, we're going to need to say, well, how do we want to run that mapping? Take a look. when you take an array and you do the dot map, one way you can use it is by defining a function right here, saying number, and then do this. Well, you can call the function whatever you want. What we're trying to do is like first letter is how do we now find the first letter of each of these? So we want to return. Now, in fact, animal. Sorry, I was not thinking here. Sorry, too much today. So for each animal, what we want to do is take the animal and get what? The first letter. So there's many ways to go about doing this. One way, perhaps just take animal as a string, and strings can be then thought of as getting the first letter would be the 0 index of it. This is actually, strings are just an array. Let's see if that works. And run. Interesting. Look what printed out. HELLOWO. Well, interesting. Hello world. That's down below. So yes, in fact, the first letter of each of these happens to spell out hello world. To make sense, again, taking an array, you can call the map. You can then, for each element in that array, give it whatever you want to call it. In this case, an animal is part of the animals. You could call it whatever you want. You could just call it element if you want to be generic about it. Doesn't matter. And then you need to say what you want to do with it. In this case, I want to return that element's first letter. To get the first letter of a string, one way to do it is to treat the string as an array itself, and then look at the 0 element. Okay. Use map to divide all the numbers in big numbers, here's big numbers, by 100. Save the return values to a variable named small numbers. So const small numbers, we know that's where it needs to get to. Start there. We want to use the map against this array. So big numbers dot map. Now, each element in big numbers, we can just call this, I guess, number. And we want to do what with it? Divide that by 100. So take a return of the number divided by 100. And it's done. Now we didn't print it out, so we don't actually see what's happening, but we can. Const.log small numbers. Sure enough, 1, 2, 3, 4, 5. Each of these was evenly divisible by 100. So again, map is just allowing us to do effectively a ForEach on an array, but instead of just doing that, single thing of just grabbing that element, it allows us to now run an arbitrary function to what to do with that element.
Question again.
Yeah.
I didn't use the curly brackets and it still said it was correct. Should I still put them there just for completion and to make it look proper and correct?
Yeah, no, you don't have to if it's just a single line like I'm doing. The curly brackets, remember, are about scope. If we go back to the lesson on scope, if you wanted to, create a block of code and then declare that this is, all together, the curly brackets help. Personally, I get in the habit of just including the curly brackets because unless you're absolutely sure you're not going to be adding anything else, which in this case, you can be sure you're not going to. I like the flexibility that the curly brackets provide, which is now I can easily come on in before this and do something else.
Right.
If you don't have the curly brackets, you're going to have to first add the curly brackets before you do that, or you're going to, break something, right?
Yeah.
So yes, to be perfectly clear about it, you don't need the curly brackets. You could have just done
Better,
this.
yeah, but better to have it.
Oh,
And
turn it up.
in the first example, if I wanna have a space between the two words of hello world, is there a way to program that as well? I don't know, how would I go about that?
One moment here. Get this back to curly brackets included so if it keeps executing. Yes, if you wanted to put a space in the hello world execution, like right now it's just doing HEL, but no spaces between each one. How would we go about doing that? At the moment, like because we're doing a mapping, it's just literally mapping this one-to-one and it's storing it in const secret message and then it's printing it on out. What you'll see is const secret message, or sorry, the secret message then calls a dot join. Notice how there's no space right here, but you could put one in. Space is a valid character. If you do, it spaces it out by 1. If you wanted to space it out by 3, just put 3 spaces. Cool.
Right. But then just the space between hello and world.
Oh, if you wanted to put just a space between hello and world, that's going to take a bit more because really like we're taking a mapping of an array and there was no space up here. I mean, I don't know what exactly you're trying to achieve. Like, you know, the easiest way to do it, you could put another element in here with, you know, I guess, sure. If that technically works, although you're modifying the input. It depends on what you're trying to achieve, but that would be the easiest way for me to think of how to add a space on in to hello and world. Just modify the input.
Right. Okay, clear, thanks.
Yep. All right, so then the filter method, very similar. This one's allowing us to take an array and remove or, you know, filter down things that don't match certain conditions. So let's take a look at some example here. Call the dot filter method on random numbers to return values that are less than 250. Save them to a new array called small numbers declared with const. So we have this random numbers. We can see that there's just a bunch of junk there, but some of them are above 250. So how do we do it? We want to first call a filter on random numbers below. So let's try it out. We're going to make a const. They said declare it with const, and they wanted to be called small numbers. Now, in order to use a filter, we first need to say, what are we filtering on? We're filtering on the array random number. So copy and paste that. Then we're going to say filter. Now, how do we declare a filter? Let's go take a look at back at the example. The filter, very similar. It's going to require that we say, what is each element called? Well, you can call it whatever you want. Like in the case of, you know, a pluralized word, small numbers, I guess this one will just be, you know, a number, sure. Then we say, what do you want to do with it? Let's pass in a function that defines what to return. So in this case, we want to return only if the numbers are less than 250. So all we have to do is just take our number that we have selected from this filter and look less than 250. Makes sense so far? But what it now wants us to do, okay, that passes that. I guess we didn't have to print it out. Now let's work with an array of strings, favorite words, nostalgia, hyperbole, fervent, esoteric, and serene. Those are some good words. We want to return any of these words that have more than 7 characters in it. Save the returned array to const variable named long favorite words. Okay, let's try it out. Const long favorite words. Again, we're going to pass in what array are we working on, favorite words. We want to use the filter function. And this is going to require us to specify what are we doing. So filter on, sure, words. How do we define those words? We only want to return if our words, or sorry, not words, but word, is longer than 7 characters. Anybody remember how to look for the length? So longer than, so we need something for the word if it's greater than 7. But how do we check if how long a word is? Anybody remember? Could be like this. Remember, when you have a word, a string, when you have a string, one of the properties is dot length. And again, this is something you just kind of have to memorize for each language, these type of properties. Okay. Keep going. The find index method. We sometimes want to find the location of an element in an array. That's where the find index method comes in. Find index on an array will return the index on the first element that evaluates to true in the callback function. So if you have these jumbled numbers, 1, 23, 25, 78, 5, and 9, and said, find the index for any numbers less than 10. Well, this is greater than 10. This is greater than 10. This is greater than 10. 5 is less than 10. That is the first one. It will then stop. It won't consider anything else. It's just going to say, go search this for anything less than 10. Pretty useful. It's kind of like a search function, but you don't have to say, you know, just search for 5. You can just say, I'm just interested in something that's less than 10, and it'll go search for that. Let's give it a shot. Let's try an example. Invoke the find index on the animals array to find the index of an element that has the value elephant and return the value of const to found animal. Okay, so you can, if you want, just literally search for an entry exactly. Or you could say find animals that have more than, 5 characters, and it wouldn't, say, oh, well, hippo has 5 characters, but that doesn't match, that doesn't match, that doesn't match. It would finally get to cheetah and would say that. So you can use this find index on any type of condition that you want to find on. Let's try this one. So we want to save the return value to a const variable named found animal. So let's start with that first. Const found animal is where we want to save it. So it needs to equal something. Now we want to do this find index on the animals. So we say for the animals dot find index. Now, how do we define this particular index? Well, we want to then say for each one of these animals, so it's animal. And we want to then define some way that we're finding it. So we could say this is the function to go and use. I want to return if the animal equals elephant. Right? So you can certainly just look directly to say, does the thing that I'm currently look like equal an elephant? If so, great. And now it's done. In this case, if we then if we console log found animal 7. Why 7? Well, 1, 2, 3, 4, 5, 6, 7, 8. Why is it 8? Why isn't it 8? Well, that's because it's starting from 0. 0, 1, 2, 3, 4, 5, 6, 7. Remember, an index in an array starts from 0, not from 1. So elephant is not at the 8th index, it is at the 7th index. All right. Let's see if we can find the index of the first animal that starts with the letter S. So I think we can all spot there's the letter S, but we need to write some code to do it. Call the find index on animals array and return the index of the first element that starts with the letter S Assign the return value to a const variable name starts with S. So again, let's start with const, starts with S. Pass in the thing that we want to filter on, animals, sorry, find index on. Find index. We can again say, look at all the animals. We'll call each one animal. Here's how we want to run it. Animal, and then, well, we need to return an animal with the first letter that starts with S. So return animal if what? The first letter starts with S would be, so when we look at the first letter, that again, it's a string animal. So we can look at the first letter is using array index 0. That would be the first letter. To compare it, we'll just use a comparison. Equals S. Let's try it. Cool. At this point now, it's going to then return the first time that it finds the letter S. Now, in the case of Salamander, that technically also has a first letter of S, but since we already found seal, it stops and it just returns that index. If we console.log starts with S, you can see 3, 0, 1, 2, 3. Okay. And remember, it is case sensitive. So if your input had a capital S is not equal to lowercase s. You'll now see it finds index 6, 0, 1, 2, 3 is not valid, 4, 5, 6. 6 has a lowercase s. It is always case sensitive. All right, similar, the reduce method. So the reduce method is quite similar in this. We can reduce down after iterating through elements in an array and then reduce that array. So if we had the example of numbers 1, 2, 4, 10, and we call the reduce on an accumulator and current value, we could return accumulator plus current value, and then it would print out the summed numbers. So it's adding 1 plus 2 plus 4 plus 10. So the first time it runs, 1 plus 2 is going to get 3. Then it's going to do 3 plus 4. It's going to get 7. 7 plus 10 is then going to get 17. Let's go and try this out. So let's practice using reduce and using console.log to check the values as reduce iterates through the array. In main.js, there's an array of numbers, 1, 3, 5, 7, called new numbers. To start, declare a new variable. So let new sum, const, const new sum. And we want the new sum value of calling the dot reduce on new numbers. So to call that, we would pass in new numbers and say reduce it. You don't need to provide any arguments to the reduce yet. So if all you do is this, watch what happens. You're going to get a type error. Undefined is not a function. Okay. So yes, you're currently reducing it, but you've not defined a function, so it's an error. All right, provide a reduce with an argument of a callback function. The callback function has 2 parameters. The first parameter is accumulator, and the second parameter is current value. Use either a function expression or an arrow function. You can define it either way. All right, it's hard. If you get stuck, take a look at how we did it up here. Some numbers, accumulator. So in this case, they're using accumulator and current value as the function, and it's doing return plus accumulator plus current value. So if we wanted to get the new sum of new numbers and reduce it, we could go ahead and reuse this accumulator and current value, map it then to say, take accumulator plus current value. Now, what we would need is the accumulator. To then keep accumulating each time. Does that make sense? This is getting a bit confusing, I hope, for some people. This gets hard when you get started, but you're passing on in this new definition of a function. We're going to then create this arrow function to then say, take the accumulator and add in the current value. You may need to play with this a bit at home to fully understand how it's working. All right, to check the value being used as we iterate through the array, add 3 statements to the function body of the callback. So we're going to add in some logging statements to see how this thing's actually working. The value of the accumulator is this. The value of the current value is this. A return statement that adds accumulator to current value. So this is to get back to the question, like, why did I use curly brackets? Because of things like this. I oftentimes have to go back and add in some additional statements. And since I already have the curly brackets, it's very easy to see where to put it. So we can now say console.log, the value of the accumulator is this. Okay. And it wants us to also do console.log this. And a return statement that adds accumulator to current value. Well, oh shoot, I guess I already did that, but yeah. Run it. So what we're seeing is each time it runs, I can now see 1, 3, okay, that set the accumulator to 4 now. Now we do 5, 9, well, 4 plus 5 is 9. Okay, that's there. And now the current value is 7. Makes sense? Log the value of new sum to the console to see the return value of calling reduce on new numbers. Console.log. And if we want to log something out, we just pass in new sum to the console to see the return value of the reduce on new numbers. 9 plus 7, 16. That's the final value getting returned by the accumulator plus current values getting set back at the new sum. While we have this code set up, let's also check what happens if you add a second argument to the reduce. The second argument acts as initial value for the accumulator. Add a second argument of 10 to reduce. Okay, so in this case, when we run it, accumulator current value, all we're doing is here, but we could, if we wanted to, pass in an initial value of 10. Now everything starts from 10. 10 plus 1 is 11, 11 plus 3 is 14, 14 plus 5 is 19, 19 plus 7 is 26. Remember, when you run a function, you don't have to provide that second argument, so it's optional. But if you provide it, then it's going to use it. Okay, that's all we're going to get to cover today. But there is a lot of documentation on how iterators work. Please go take a look at some of the documentation as a homework, and go take a look at how some of these other arguments like the .sum method works, and try some of these out. I do think this is starting to get a bit more complicated than our old class lessons. If you're confused, by all means, put some examples in the chat, and we'll try to talk about it offline. And I hope you guys keep trying it out. I think we're finally starting to see some of the more complicated things that you can do. These are higher level programming that gets more abstract. So take some time to practice it. It is a bit hard when you first see it. All right, I'll stop the recording, but if there's any questions, just let me know.
How would this be used then in the context of blockchain technology?
Good question. I know. we're deviating so far away from the Web3 part and just doing the rudimentary of, you need to know the basics of programming. And that is the sad reality of any programming language, is like, there is some of this where you just have to know it. Absolutely, though, we use this type of JavaScript on front-end web design all the time. Imagine you had a long list of transactions. You're not going to for loop over the list of transactions. You're very much going to for each. If you needed to be able to then, find transactions that meet a certain condition, you might use a map or a filter. So it absolutely comes up all the time on front-end transactions. And from a JavaScript perspective, we use that quite a lot. What's interesting about the Solidity smart contract is I don't often find similar concepts in Solidity. It behaves quite different. We more often are using for loops, but even then we try to avoid them because, well, they're gas intensive. So good question. I knew this lesson would be kind of dry and complicated, which is not really anybody's fun definition of fun, but it is essential to memorize some of these basics before we can get into building a real app.
Clear. Yeah, makes sense.
Yeah.
Okay. Thank you.
No problem. Great question. Anybody have a question?
Thank you, Ben. This is Mark. Good class today.
No worries. Thanks, Mark. Thanks everybody for coming on in. I will post the YouTube, and if you guys get to some confusing sections, just reach out to me on WeChat. Do practice this one. This one's a harder lesson than the rest. Okay.
Quick question. Is it going to be the same schedule over the vacation time, or so do we still have next week, or?
Yeah, I will try to give you guys a heads up notice. I do want to try to wrap up getting through the end of this basic stuff by end of year. So if we go back out to the course menu, all that we have left, and there's not much, we're at iterators. All we have to do is objects, and that's it. So I want to at least knock off objects. And once you've done that, we can literally start doing some of the actual Web3 development, because you'll have all the basics now underway. So I'm hoping to hit the new year, or even like give some preface to the new year by showing, what is it called? Crypto Zombies. We're next going to jump into this.
You're not sharing anymore. I don't know if you're meant to.
I am meant to, and I thank you. One moment. So check out Crypto Zombies. So now that we have the fundamentals of JavaScript, we can do something like this, where it's a blockchain decentralized app to build a game. Sadly, this requires you to have some basic knowledge before we can jump on in and start the course. A little bit of it is going to be repeated, but then you'll be able to breeze through it without all the confusion. So I'm hopeful that we can then start to do this as a next step, where you're really going to start to combine the basic JavaScript you have with now actually using smart contracts. Cool?
Yeah, it looks fun.
It is fun. And a lot of my friends who got into blockchain quite seriously literally started with this. So don't, even though it says beginner, don't diss it. It's not just for kids, like for fun. It actually has created some of the best blockchain developers I've ever met. So it's actually really, really good.
Nice.
We'll try it out. Okay. Have a great evening, guys, or day, and I will see you all next week. Okay.
Okay. Good night.
Thank you. See you.
Yes,
Bye.
bye.